Hi everyone, good morning. I hope all of you are good and I am also fine. So today I will take another class from mathematics series from class 12, and the topic is homogeneous differential equation from the chapter differential equation. Okay, so what is actually homogeneous equation or differential equation? How can we represent it? The general form of homogeneous differential equation is dy by dx equal to f of y by x, right? Now how can you solve this? To solve a homogeneous differential equation, we have to put y equal to bx. Okay, if it is in the dy by dx form, and if it is the dx by dy form, then we have to put by x equal to by. So now there is one question. First question, the question is how the differential equation is homogeneous and solve it. So let's try. So I write the differential equation here: x square plus xy dy x square plus y square dx. Okay, so now dy dx is what, sir? X square plus y square by x square plus xy. So now I dividing both numerator and denominator by x square. If I divide by x square, so what will be came here? It will be x square by x square, y square by x square, and here x square by x square and xy by x square. Okay, so now after simplification, what became? It will become 1 plus y by x whole square, and here also 1 plus y by x. Okay, so now dy dx is equal to function of y by x. Okay, is a homogeneous differential equation. Homogeneous differential equation. Okay, fine, it is proved. It is a homogeneous differential equation because it is in the form of dy by dx f of y by x. Now how can I put this? I put in let, suppose this one is equation 1, let or put y equal to bx. So dy dx b into d dx of x plus x into db dx. So b into 1 plus x into dv dx. Now therefore from equation 1 we get what? We get b plus x into dv dx is equal to 1 plus y equal to bx. So bx by x whole square plus bx by x. Okay, fine. So here it will be x into dy by dx. Here x will be cancelled out, so 1 plus b square by 1 plus b. So x into dy by dx is equal to 1 plus b square by 1 plus b minus b. So x into dy by dx is equal to 1 plus b square minus b square. This one will be cancelled. Okay, so x dy dx is equal to 1 minus b by 1 plus b. Okay, now simplify this one. It will be dv by dx. Sorry, it will be dv by dx. And it will be dv by dx. Okay, so dv by 1 plus b by 1 minus b and dv equal to dx by x. So here 1 minus b dv b by 1 minus b. So how can I do this one? If I write here 1 minus 2 minus 1 plus b by 1 minus b dv, it is log x plus c. So it will become integration 2 by 1 minus b dv log x plus c. It will become 2 into integration db by 1 minus b. Here it will cancel out db log x plus c. So 2 into log 1 minus b log x plus c. Just put the value of b here. If you put the value, it will become 1 minus y by x minus y by x equal to log x plus c, right? So it's so simple. So let me explain again. This is the differential equation. So we have to first prove this is a showed this is a differential equation. So how can I show this? You have to convert the differential equation in the form. Okay, so I write this equation and dx is here and I cos multiply this, and after that I divide both numerator and denominator by x square, and this became a homogeneous differential equation. And just to solve the homogeneous equation, we have to always put y equal to bx. After that I differentiate with respect to x, I put the value of dy by dx is dx and y equal to bx. Okay, after simplification this came. Okay, here I do a one integration, it became 1 plus b by 1 minus b. I write 2 minus 1 plus b. After that it will be 2 minus 1 minus b, and after simplification this one came. And after that what I will do, just put the value of bx is what. Okay, so our next question is this one. This is the one differential equation. So we have to put it is a homogeneous differential equation. After that we have to solve it. So first we write here, we write the differential equation y minus x tan y by x. After that I x y by x minus x by x tan y by x. So look at here, I divide both side by x, so it will become like that. So if x's will be cancelled out, and it will become y by x minus tan y by x, and it is equation 1, and it is in the form of differential. It is a, therefore it is a homogeneous differential equation. Okay, now putting y equal to bx, so dy by dx is equal to b into 1 plus x into dv dx. So b plus x into dv dx. So give equation 2. So from equation 1 and 2 we get b plus x into dv dx is equal to b y equal to bx, y by x bx by x, here 10 bx by x will be cancelled out. So b plus x into dv dx, b minus 10b, b will be cancelled out. So x dv dx is equal to minus 10b. Okay, now come here, dv by 10b equal to minus dx by x. Okay, and I take integration here, 10b minus dx by x plus c. It will become cot b dv minus log x plus c. So integration cot b is what? Integration cot b is log of sin x, sin b equal to minus log x plus c, or log sin b plus log x plus c. So it will be log of sin b into x equal to c. Okay, so sin is what? B is what? Y by x. Okay, it will be x plus c. So sometimes we have to simplify in this way also, x into sin b equal to e to the power c, or x into sin y by x is equal to c constant. Okay, I am simplifying this one, right? So this equation is given, and this equation is came in CBSE 2006 and 9. This equation this question came CBSE 2009 and 2006. Okay, so I write the equation first, and after that I divide both side by x, and after simplification it is become f of y, that is dy dx is in the form of f of y by x, is not it y by x. So it is in the, it is differential equation. So it is proved differential equation after that, and I solve it by putting y equal to bx. After simplification this will become, okay, here is dy by dx is this one, here is dy by dx is this one, and I equating the equation 2. After simplification this one became, okay. After some simple integration, you can put the value of p here also. I just simplified this log a plus log b equal to log a into b, and after that I change the lot into e to the power c, that is it will be c, okay. So now next question. So our next question is this one. Show that the differential equation is homogeneous and solve it, okay. And this question is came in 2010 and 13, so a little bit harder this one. So I just first write the equation x cos y by x y dx plus x dy equal to y sin y by x x dy y dx, okay. Here from that we have to find first our dy dx is what. So I am multiplying this one, cos y by x to y dx plus x square cos y by x dy, here xy sin y by x and dy minus y square sin y by x dx. So now here is dy and here is dy, so I write cos y by x dy, and I interchange this part here, it will become xy sin y by x dy, and here this one is y square sin y by x dx, and here will be x cos y by x into y dx. Now if I take dy dx is common, therefore we can write the dy by dx is what, it will become like that, okay. It will become dy by dx, it will be given then on dy y by x minus xy sin y by x. Here if I take minus is common, it will become y square sin y by x plus xy cos y by x, okay. So if I multiply by both equation by x square, so it is became x by y whole square sin y by x y by x cos y by x, okay. So here if I multiply it will be cos y by x and minus y by x sin y by x, okay. This one is equation 1, and I considered, so dy by dx is equal to f of y by x is a homogeneous differential equation, okay. Now for solving, putting y by x equal to b, so y equal to bx, so dy by dx will be b into 1 plus x into db dx. This is equation 2. So from equation 1 and equation 2 we get, what will we get? We get here b plus x into db by dx is equal to what? Y x b square sin b plus b cos b. Here is minus, and here cos b minus b sin b. So if I write in this way, b square sin b plus b cos b divided by b sin b minus cos b, okay. So now therefore x into db by dx, write b here, b square sin b plus b cos b minus b square sin b minus b cos b by b sin b minus cos b. So I equate in this equation 2, and after that this one become, I common multiply the minus in the in this way. Okay, I take the minus as common from this, and minus minus will be cancelled out, it will be plus. After that I side change this b, I came the right side, and after that I doing LCM. After LCM, what will become? This will become. I doing some step, 2 or 3 step here. Okay, so b db b dx is equal to, this one should cancel out, and it will become plus, isn't it? Plus, so 2b cos b by b sin b minus cos b. Okay, fine. So b sin b minus cos b by b cos b db equal to dx by x. Now I take integration. I just side change this one. Okay, I consider, if I take this one is b, it will become, suppose b cos b equal to z, it will become b minus sin b plus cos b into db equal to dz, is not it? So it became minus dz by z equal to 2 log x plus c. So log z to log x plus c. So z is what, sir? Z is here, z is your b cos b, here 2 log x plus c. Log b is what? Y by x, sir. Cos b is y by x, sir. Log x plus c. Okay, so this is the answer. This is the, we can solve in other way also. Okay, so this is the answer. So how I am doing, I first try to prove this differential equation is a homogeneous differential equation. After that I solve. For solving this an equation, we put y equal to y by x equal to b. After simplification, this one is simple integration. After doing this in scheme, okay, I take here b cos b is z, and I differentiate both sides. After that, what will become? If I take minus as common, so it will be b sin b minus cos b, and this will become, that is b sin b minus cos b db equal to minus dz. So it will be dz by z. So dz by z is log z. After that I put the value of z, and after that I put the value of b is what. Okay, so our next question, question number 4 is, show that the differential equation is homogeneous and also find its particular solution. So how can you find its particular solutions when x equal to 0 and y equal to 1? When x equal to 0 and y equal to 1. Okay, fine. So I just take this differential equation 2y, then y e to the power x by y dx plus y minus 2x e to the power x by y dy equal to 0. Okay, fine. So y 2x e to the power x by y dy equal to minus 2 y e to the power x by y dx. So I write dy by dx is equal to minus 2 y e to the power x by y. Okay, y e to the power x by y dy by dx, and it will be minus y 2x e to the power x by y. So therefore dx by dy is in the form of y minus 2x e to the power x by y, and here minus 2y to the power x by y. So dx by dy, you can write 2x e to the power x by y minus y by 2y e to the power x by y, right? So if I divide it by y on both sides, it is in the form of dx by dy, it will become 2x by y e to the power x by y minus 1 by 2 into e to the power x by y, and it is in the form of x by y is a homogeneous differential equation. Okay, proved. It is proved. Now we have to solve it. So for solve, if it is in the form of dx by dy, in the previous case what I am putting, y equal to bx, because it is in the form of dy by dx. Now it is in the form of dx by dy, so we have to put x by y equal to b, equal x equal to by. Okay, so dx by dy it will be b into 1 plus y into dv by dy. So b plus y into dv by dy, this is equation 2. So now from equation 1 and 2, what we will get? We will get b plus y into dv by dy is equal to 2b minus 2b into e to the power b minus 1 by 2 into e to the power b. So y into dv by dy is equal to 2b e to the power b minus 1 by 2 e to the power b minus b. So y into dv by dy equal to 2b e to the power b minus 1 minus 2 e to the power b into b by 2 e to the power b. This one will be cancel out. So y into dv by dy equal to minus e to the power b. So 2 e to the power b dv equal to minus dy by y. I take integration here, d to the power b dv minus dy by y plus c. Okay, so now integration this on, it will be e to the power b, here it will be log y plus c. So now put the value of b is here, b is e to the x by y minus log x by y plus c. This is equation number 3. So we have to put so this is the solution. Okay, this is the normal differential equation solution, solve is solved. This one is proved. Three parts are there in the equation. First we have to put it is a differential equation, then we have to solve it. First I proved it is a homogeneous differential equation, then I solve it. Now we have to find out the particular solution of it. So when x equal to 0 and y equal to 1, so I have to put x equal to 0 here and y equal to 1 in this equation. So if I put here, what will become? C will become constant, c will be came out is what. After that I have to put in equation 3 the value of c. Okay, so now putting x equal to 0, y equal to 1, so it will become e to the power 0 minus log 0 plus 1. So e to the power 0 is 1, so minus 1 plus 0. C will be 2 plus 1, that is 3. So now partial solution will be what? 2 e to the power x by y minus log x by y plus 3. So this is the partial equation. Okay, so this is the partial equation. So this is the partial equation. So this is the last question. There are 4 questions. If you follow this, you can solve any one of the homogeneous differential equation, any one. Okay, so first we learned the what is homogeneous differential, how can you represent it. After that I solve 4 questions. That is, it's not 4 questions, 4 previous year questions and 4 different types of questions. Okay, so if you follow this only 4 questions, you can solve any one of the differential equations, homogeneous differential equations, especially from any books, it may be CBSE, it may be state board, it may be ICSE. Okay, so thank you for watching. Have a nice day.